Hello, welcome. This is going to be Shenzhen I, a game from Zachtronics that seems to be sort of in the vein of TIS 100. That game was a great time. Opus Magnum was different but also cool. I want to learn a little bit more about the Zachtronics library, and I want to do it with this. So I'm starting here on the desktop for a few reasons. This plays a little intro animation when I start it for the first time. I had a test recording that I did, then I had to go delete my save file so I'd see the intro again. Then I had a non-recording where I talked to myself for 10 minutes and nobody could ever hear me. So this is like a take 3, sort of. Let's just open this and do the intro. I have the manual back here, so it's one of those games. Right, mission statement for this. I became an engineer because I wanted to make things. This is not that. But after I graduated, the reality of the world caught up with me. That's just not something we do in this country. Not anymore. It took me a while, but eventually I realized it was true. I'd have to go somewhere else. Somewhere I could do what I was meant to do. China, apparently. Alright, something OS. Don't know enough Chinese to read those. Live camera feed. Alright. Huatiangbei District. Cam 4 live. Alright, hazy. 21 Celsius. When I opened this a moment ago, it was only 20. The temperature went up since my not recording. Air quality very poor. Drone activity moderate. Okay, so this button would open the PDF I already have open here. Yeah, you can see all my stuff. That's fine. I can see I'm actually recording this time. Check it out. When I went to the PDF, that was what clued me in. So the manual tells me to print it out, but I'm not going to do that. Right, sorry, got distracted. Mission statement. I want to learn another assembly language, since this game appears to teach one, kinda like TIS 100, and just kinda have that experience again, but in a different format. Gonna try not to get too hung up on optimization as usual, but I do want to try and solve all the puzzles, at least in some capacity. And I have a whole list of Zachtronics games. I'm getting to know the pattern of a Zach-like, as they're sometimes called. And I want to see another one. So, anyway, these are settings. I can play in Chinese, but I don't want to do that. I do not want auto-formatting right now. I don't like that usually. I'll do it myself. Alright, I'll get to the manual, but first, welcome! From this person, leader. Dear new employee, thank you for joining Shenzhen Longtung Electronics Company Limited. We aim to become a world-leading company in the electronics industry and a respected brand with products in homes, offices, and public spaces around the world. Longtung Electronics was founded on the following principles. Diligence. This means both diligence in your work and diligence in your life. When you encounter a problem, do not give up. Even if you are not talented, by working at it every day, little by little, you can achieve the goal. Connections. The process of creating electronics is the process of creating connections between different components. In the same way, we do business by making connections with other people. Therefore, it is important to always be making connections in your work. Salubriousness. That's a new word for me. An unhealthy mind creates an inefficient design. An unhealthy body builds a defective product. Follow correct eating, correct behavior, and correct thinking in order to maximize your potential. Please keep these principles in mind as you contribute to our efforts. Something. Wang Yonghong, CEO. Like that company. Alright, Karl Teskey. Ah, fresh meat. Just kidding. Welcome to southern China. It's alright, I suppose. Except for the heat, smog, and lack of decent cheese here in Shenzhen. Still better than any engineering gig I can find back home in the UK, though. I'm assuming you ended up here for similar reasons. From Joe. Yo, so I heard you're our newest ace engineer who's going to kick ass and take names, am I right? You've probably heard all about me already, but I'm the product guy who loves to find amazing opportunities and make deals happen. Let's do this! So each person gives you a little sample of their personality here. And this is reminding me uncomfortably of an office job I had once in some ways. They're nailing some, some of this vibe for sure. Never worked in China, but Greetings and welcome to the team. As you've already been made aware, we are on a major international expansion effort and we are very eager to see you bring your skills and expertise to our company. VP of Product, David P. Solomon. That probably says ni hao, I'm gonna guess. I don't know though. My name is David, or something in Chinese, and I was brought on to help Longtung with its international push. Though I've only recently moved here from San Francisco, where, I should point out, there is a very vibrant Chinatown, I am really loving it so far. It is truly fascinating to see a culture at once so ancient and so modern from up close. I am sure we will be working together closely to create many successful products. Something in Chinese I can't read. David P. Solomon, Product Manager. Hello, my name is Ya Zhang. I am the Chief Staff Engineer, your boss. I have not managed many foreign workers before, so please understand if I make a mistake here or there. Anyhow, I will send your first job shortly. Yeah, he seems straightforward enough. Alright, important, read the manual. I know, you're so good at engineering systems and life in general that you haven't needed a manual in ages, right? Well, trust me on this one. You really want to read the manual here. Even better if you keep it handy as you work. Don't be like the non-manual using person who quit just before you started and whose name shall never be uttered again. Alright, and then this goes to the actual first puzzle. Create a working design of the product view histograms. There will be histograms, of course. It is a Zaclic after all. This product is an imitation, mock, security camera. It has 2 blinking lights. The first light blinks in a regular pattern. The second light is an internet light, so it should be blinking in a more random, intermittent pattern to resemble data upload. As you will notice, the design is partially complete already. A previous engineer quit, before finishing the assignment. Note the timing diagrams in the verification tab. When simulate, your outputs should match those expected values as indicated. Let the simulation run until it has passed all of the test cases to make sure you have a proper solution. So this sounds like an Opus Magnum style thing where, you have to go through enough verification steps that it's satisfied with what I've built. I'm absolutely certain you'll do better than the last person. And also, we're making a fake security camera, so the illusion of security without the expense, I guess. Okay. So yeah, this is clearly the puzzle solutions list. This doesn't have tooltips, but I assume this is copy. I assume this is rename. I assume this is delete. That seems clear enough. All right. So creating product design, let's do it. This is how far I got before I did this and saw this window blank and realized what I had done wrong. So anyway, I don't know what I'm seeing on this screen, so I'm going to let the manual tell me. Let's do the manual reading thing. So printing instructions, Shenzhen Longtong, technical document organizer, all right. I'll write that. Application notes. Okay, so here's my assembly language. Not, move, jump, slip, slicks. What do those do? Add submul, not, dgd, dst, dgt. I don't immediately know what those might mean. Test equal, test greater than, test less than, test compare. Okay, yeah, so this is a CMP. This is familiar to me. Let's see, what does this mean? This is like, if less than do one thing, if equal do another thing, if greater do a third thing. So this is like a 3-way branch. Maybe. Typically. RI. Register, integer, register or integer. Pin, register, label. Okay, so I think the manual here is part of the puzzle. This is not like a manual for me to understand how to play the game. This is a manual for the character I'm playing at his new job in a foreign land, where he's just got to figure out what is going on. Okay, so same range as TIS 100, I believe. Labels used and operated must be defined elsewhere in the program. Which game came first? I think this is after TIS 100. Doesn't really matter. ACDAT, P0, P1, X0, X1, X2, X3. Okay, so I got a bunch of registers now. That's nice. Why is this so hard? So that's previous engineers' work. So let's poke at this for a moment and learn about it that way. This looks like a cost. What is this? Yuan, I think, is the currency. So what's this? All right, that's one of these. I could put another on the board. Not on board. Okay. Can I get rid of it? All right. Step, advance, simulate, reset, pause. Okay, and then home is that. Back is that. So this is like a Android smartphone controls, basically. Oh. All right, so active network. Yeah, I should look at my manual again. What else are you going to tell me? Some progress and a suggestion. Good morning! Just a quick update for you today. First off, I've placed your resume with 2 new agencies. They specialize in industries a little different from yours, but you never know where a match might be made. This is like before what I just saw in game. Also, yeah, when I highlight text in this PDF viewer, it moves around a little bit. I've also reached out to a few more of my colleagues across the country, letting them know to get in touch if they hear of anything. Finally, I followed up with Electromotive again, but they keep stalling. At this point, I think it's safe to say an offer won't be coming. You've been with us for a while now, and I appreciate your trust, so I want to be honest. The likelihood of us finding you something that genuinely makes use of your skills in the foreseeable future is rather low. This isn't because of any lack of qualifications on your part. It is simply a reflection of the realities of the time. We'll keep trying, of course. I just wanted to ensure you kept some realistic expectations in mind going forward. So this is like looking for a job in my character's native country, which is not China. Some English-speaking place, that's all I know about it. Could be the UK like Carl, could be somewhere else. I know you've said you were hoping to stay in the country, but it may be time to reconsider that stance. Many of the people we represent have done stints overseas and report that it is an eye-opening and in some cases career-enhancing move. I don't have a lot of contacts in that particular arena, but I can point you in the direction of someone who I know has some experience working with Chinese electronics firms. Let me know if that sounds interesting to you and I'll get you two introduced. Margie Fish, President, FRP. The journey of 1,000 miles begins with a single step. It's made to look like a URL, but it isn't quite one. Oh boy, how much of this is there? Just the 2. Okay. Great chatting with you, Jesse Huang. Hey, just wanted to follow up on our call. As I mentioned, the company is called Longtung Electronics. They're not exactly one of the biggest players, but they've been running a stable business for a while now, and that's always a good sign. Up until now, they've mostly done manufacturing subcontracts, so traditionally their design engineering team has been relatively small, but they're looking to grow the department because they want to create new products in-house for both domestic and international markets. The position is located in Shenzhen, China, which is just across the border from Hong Kong. The pay is competitive for the area, which I think you'll find more than adequate for living there. I forgot to ask if you had family, but whatever your situation is, you'll find Shenzhen is a modern, fairly international city. There's even a McDonald's right downtown. If there's anything I might be able to do to help you feel more comfortable with the idea of relocating, let me know. I've helped many engineers like yourself find opportunities in China, and I'm pretty familiar with the ins and outs. Looking forward to hearing from you once you've had a chance to chew it over. Yes. All right. So, visa application, People's Republic of China, really going through all this, huh? Okay, can I learn about myself? I guess I choose. I guess I'm supposed to fill this out because I printed this, supposedly. Chinese characters if given. Alright, what can I learn about this? The date format that I like, Not this nonsense one that other Americans use. Okay, embedded systems engineer. Employment. Oh, we're in the future here. Okay, got it. See, learning some stuff. All right. Shenzhen Longtung Electronics. I think that's how I would say that. Longtung should be how those vowel sounds work. I mean, it looks like Longtang, but I don't think that's what it is. Mailing address, contact person, ever been refused, do you have a criminal record? Sure. Alright. Do what now? Alright then. 2 interfaces, limitless possibilities. Simple I/O and X-Bus. Alright. 0 to 100. Do I know what I'm working with here? Okay, so let's start with this. Active and network are simple outputs connected to LEDs. Control the active and network outputs with fixed repeating signals as indicated in the verification tab. Okay, we've got 2 tabs here. Here we go. Here's our timing diagram. All right. Oh, I can breakpoint. Neat. Okay. So that's what the thing I'm building looks like. This is the, what was the description again? Go back. How do I, okay. The first light blinks in a regular pattern. Second light is an internet light. Got it, okay. So this is the, just like status light, this is the internet light. So medium pulse, short pulse, silent, and then, okay, that's not very, that's not going to be too convincing, but we can pretend. Alright, so back to the manual. So this is simple I/O. There will be numeric input to, or output rather. Okay, so I don't want to read all of this right now, I just want to know what I need. Okay, CPU can use, yeah, sure, time unit. Is this a time unit, probably? That's my guess. Very large number of instructions within one time unit. Are you going to tell me how many? To advance the beginning, next time unit, go to sleep. Slip, okay, that's the sleep, got it. Number of time units to sleep. Square wave. And that is on 100 for 3 time units and off for 3 time units. Okay. Move 100 P1, sleep 3, move 0 P1, sleep 3. Okay, so you're basically giving me the program I would need for this. I see 0 for 6. And 100 for 6. Okay. Move 0, P0. Is P0 what I want here? Sleep 6. Move 100, P0, sleep 6. Why is this so hard? That should work, right? Sure. So that works fine. Okay. That one's verified. So, I mean, I can just... Oops, whoa, I misplaced. How do I... Whoa, okay, okay, okay. Calm down there. Can I undo? I can. All right, so working with physical components here. Be careful where you place them. This goes here. Okay, right, active and network. So I can do this. Wires seem happy. And I mean, I don't even need to read the manual for this. I can clearly just... okay, so that's 4. Just infer from what's here. This won't be efficient, but, you know, it's fine. And I think that's... something looks wrong. Right, I'm on 0. I still need 1 P0, sleep 1. And then it will loop and do the rest of this. Okay, so this should just work, right? No. Something went wrong. Oh, wait, what did I said 1 instead of 100. Okay. Alright, blink, blink, blink. I've successfully completed 1 test run. Let the simulation continue running to complete the verification process. Power usage, huh? Alright. So can be done with less code, of course. I haven't learned the language enough to know how to write the second one of those more efficiently. That sounds fine. I get an idea of the flow of this. Thanks for your prompt work on the blinking lights. Looks okay. Yeah, alright, cool. Shenzhen days, why are we even here? Hi everyone, we've had a bunch of new signups this week, so let me reintroduce myself. I'm your host, Tilly Liu, and I run this fun little mailing list for expats in Shenzhen. I'm here to demystify some aspects of life and culture here, along with a side helping of color commentary. Sometimes just the color commentary. Yeah, I get distracted. Today's topic is, why the heck are we in Shenzhen? No, really, like, why are we here at all? I don't mean in the immediate sense. Sure, we all have some job or some businessy thing to do. But let's talk about the larger factors at play. We're here because Shenzhen's been one of the fastest growing cities in the world for the past few decades, ever since it was declared a special economic zone back in 1980. We're here because it, and really the entire Pearl River Delta region, is a sprawling megacity wholly dedicated to trade, manufacturing, and services, a giant economic machine. We're here because what's possible in Shenzhen really isn't possible. Really isn't possible many other places in the world, certainly not at the same scale and cost. So where's all this capability headed, in the future? Are we going to just make more stuff, more products and things until the world is buried in crap? I guess I'm asking, what is all of this incredible growth for anyway? I have some ideas, but that's a topic for another day. All right. Replacement factory module. Our factory floor has some examples of older equipment that require control signals to be amplified. We had a device to adjust signals for this type of machine, but recently it was broken, smashed. This little, writing tick that Jiajang has. It's kind of funny. This is an appropriate project to teach you about inputs. Smashed? Hang on a sec, what happened? Is everyone okay? No need to worry. All right then. Sure. Let's do it. I'll read the manual when I feel like I need to, but I was able to intuit everything I needed from that previous puzzle. Anyway, I could have optimized it more, but... okay, MC 4000. 3 somethings. So the MC 4000 is the... Oh, hold on. Wait. Control signal amplifier. Control in, simple output, connected to factory equipment. Oh, now wait a second. Did I... Oh, solitaire. Alright. Show me this again. Did I ever finish reading this? Active and network are simple outputs connected to LEDs. Control the active and network outputs with fixed repeating signals, as indicated in the verification tab. Yeah. Okay, I read that. There may be multiple pages here. There's a profiler. Anyway. Right. Control out's a simple output connected to other factory equipment. The signal from control in should be multiplied by 2 and copied to control out. Here we go. Okay, so this is just signal multiplier. Alright, this is pretty familiar. So, control in's going to go to... So, what's the difference between X and P? That's my question. Okay, so we're not at X bus right now. This is going to just say... Yeah, it's a simple thingy. Just amplify. Let me skim this at least. Simple I/O pins can be read or written at any time with no regard to the state of the connected devices. XBus, however, is a synchronized protocol. Data over XBus pins is only transferred when there is both a reader attempting to read and a writer attempting to write. Okay, yeah, so TIS-100 port behavior, got it. If a read-or-write is attempted without a corresponding operation on a connected device, the operation will block. As you would expect. Make sure you get enough sleep. Okay, yeah, so sleep for time units. I think this is just telling me that if I don't sleep, it'll basically execute as many instructions as it feels like until I decide to sleep. Like, I don't think there's a component of timing synchronization as far as instruction count goes. I mean, this is 2026, Well, it's at least 2026. It's later than that. CPUs are very fast. This is not the 70s or whenever TIS-100 was. So that actually means something. Skyrim generator, yeah, okay, so that was like what I wrote. Now hold on, wait, okay. IO pin P1. Then what's an X pin? I want to know. Touch activated live controller. Well, okay, so P0, X1, X0. So what's the X? Detect the rising edge and advance the light to the next intensity level from off to 50% to 100% and back to off. Oh boy. 2MC4000. Okay, so the MC4000 is this thing. Computed over X bus. Oh, X bus. X bus. X1, X0. This is not X, so I probably just like can't even do that. Pin type mismatch. I gotcha. Okay, so right click removes, left click places. Okay, I understand now. It looks like I could use less wire. Whoops. If I... How do I pick this up and drag it? Is there a way? Like once it's placed, I just can't? Oh. Modifier key or something? Is this... Okay, here we go. There we go. No, wait, that has to go down there anyway, so this doesn't save me anything. Okay, that's fine. Oops. Okay, right. So, that's the difference between X and P. So I know that now. Verification, right. So this will give me some input. So I need to know how to read from P0. And that example there was basically telling me... Hold on, what is my instruction list, though? It's way up here. Okay, so this is the one that I'm going to keep handy, probably. This is where my scroll will usually sit. So it'll be move. Maybe. Maybe not. No, move would just be like to move P0 to P1, right? I need to read it and multiply it. I have a multiply command. RIR. Hang on. So register or integer to register. Pin register. SLX. Yeah, so move doesn't operate on pins? Is that what I'm seeing? Alright, let me look at the this example down here again. First microcontroller reads from the capacitive switch and simple I/O pin P0. Yeah, okay, so that's the touch. Sends either a 0 or 1 over X bus to the second microcontroller every time unit. Neat. 0 means not touched, 1 means touched. Previous reading, first microcontroller transition from low to high, of course. So the current state in its ACK register. So an Xbox value from the first microcontroller is SLX. Oh, sleep on X bus, probably. Increments ACK by 50 if the value is 1. When it goes past 100, resets back to 0. Resulting value is then used to drive the light using simple I/O pin P1. Alright, got it. So X bus communicates between these, but the I/O is simple in, simple out. Complex internal. I see. And the instruction limit is very low. This is fewer lines, fewer instructions than TIS 100 cores got. Those got 15 each. This is only 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. Wow, that's not a lot. Okay, so not going to be putting a lot of code in any individual one of these. What these pluses and minuses? Okay, so test for equality. ACK 0. So if your register has 0 in it, right, and here's my register. ACK state power. Detect a rising edge in touch. P0 100. Move 1 X1. Move 0 X1. Move P0. Okay, so move can just take this to ACK. Sleep 1. Okay, so I think what I'm seeing is I can do move P0 ACK. This font's pretty small again. That's just gonna have to deal with it. Then I want to mul ACK 2. Can I do that? No. I have too many operands. Is it mul 2? Right, because that's the only thing. I have only one register. Now what? Now what? What? What's the problem? You're still complaining. Shouldn't this have gone away? Alright, whatever. And I probably need to sleep one, I would guess. Could that be all that I need? It could be. Is it? Nothing's happening. Alright, so something is wrong with Mull too. Is that not the instruction? Where are you at? Wait, what? Mull RI. Sure. Not all registers are available on all microcontrollers. Wait, oh yeah, so integer, mul 2. Presumably multiply this by 2. Step. Okay, it's 25, exec, power 1. 50, yeah. Move ACK, P1. 50, going out here. Input 25, output 50, yeah. Sleep 1, yeah. Move P0, ACK. Mul 2. Move ACK, P1. Sleep 1. Why doesn't it go? Did I, like, confuse this with that compile error? What's going on here? How do I reset you? Okay. That fixed it. So by putting an error on that line, it broke that line of the thing forever. Is this like faulty hardware or something? So that might be a thing I'm dealing with now. This worked, but there's like something else going on here. I strongly feel like this is intentional. Like, I think this is showing me there's a fault in that hardware. I might have to, like, throw away this this piece of hardware if I make an error on it. And that just, like, consumes the line. So I have to type real carefully, maybe. Maybe. Okay. So, I don't think that's a bug. I think that's intentional. Looks good, thank you. Take care, yeah? Okay. Well, so that's showing me what's going on here. This is pretty cool. Looking forward to digging into it more. This is, there's a little bit of a slow start, but that's fine. I'm happy to take my time here and have the full experience. Alright, cool. See you next time to do more engineering.